The document says 2 ways of creating threads. This actually only discusses one. We may talk about the other one. We talk about extending versus implementing, right? 2 methods of inheritance. Have we talked about inheritance at all? Okay. So what we do in order to get our multi-threaded application to work is we're going to extend a class called thread. The way we do that is we just put extends thread, and then we have to write our own method, which overrides the default method for thread, which doesn't do anything. We call this method run. It does some work as a for loop, printing stuff out. Then later on, when you want some thread to do something, when you need a thread to do something, you create a new thread, worker being the name of our class. That was a thread. And it calls worker1.start. Now the method we overwrote was called run. This is kind of a little bit odd that we write a method called run, but then when we're ready to start it, we call a method called start. That's a little bit counterintuitive, but what happens is start is provided. We inherit that from the thread class, and then start uses the run method. So we don't call the run method directly. We call start. Start, what it does is it builds the thread, sets everything up, and then it calls run. Common mistake is to think that you call run directly. Okay, so we're going to do that. We're going to create a class that extends a thread. Maybe we'll even be good programmers and put these in their own classes, unlike what we usually have been doing in their own files. All right, so new application, let's call it thread example, or whatever you feel like calling it. Now we have a main, but let's come over here to thread example, the package for it, and add another class called worker thread. So new Java class inside the package, worker thread, capital W. Now this thread extends Java's thread class. Create subclass. Don't know what that's going to do. We're not going to do it. This is a subclass of the thread class. I'm kind of puzzled as to see why there's a little option there to do that. Okay, all it needs to do is have a run method. Run doesn't even return anything. Public, so that it can be invoked outside of this class, it has to be for our main client to access it. Void, run, it doesn't take any parameters. That can be kind of a drag. Now let's just put a for loop in it. For int I is equal to 0, I is less than 20, I plus plus, system.out.print, line, counting, plus I. We're going to come back and modify that a little bit. Then we want to sleep for a minute. Thread.sleep for a second. Now that's going to give us an error because thread.sleep can throw an exception. There's a method in the thread class called interrupt. If you need to stop that thread from sleeping, you call interrupt. It wakes up and it does something. Like if your application needs to quit right then on the dot, you could call dot interrupt and try to kill all your threads. So we have to handle a try catch for it. So the try looks like that. The catch is interrupted exception. And there's an import for that up here, I believe. Nope. What do you know? If you do what I just did, which is use NetBeans to generate the catch statement for you, it adds the reference to the logger. Just delete that. And system.out.println thread interrupted. I love this hint. Thread.sleep called in loop. Yeah, of course it was called in a loop. That's really the only time you're going to call it. I've never understood why NetBeans decides that that's a problem. All right, I'm going to add comments. This is the end worker thread class. This is the end of the run method. That's the end of the for loop. I'm going to compile it but not run it because we're not calling worker thread. I know I type way faster than anybody else. Are you done typing, Miranda? Okay. I can see their hands, I can't see yours. I'm not calling you out, I'm just asking. Okay, so go back to thread example, and we're going to start the threads the wrong way with .run. Let's create two threads. Worker thread WT1 is equal to new worker thread. Worker thread WT2. Maybe I should have made it W1 and W2. Sounds good to me. W1 and W2 is equal to new worker thread. Now we're going to call that run method we wrote. Seems like a natural thing to do. W1.run, W2.run. This run method doesn't actually start it as a thread, though. It just calls that code. It's even giving us a warning. NetBeans is saying, this really is not the right way to do it. I wonder if the hint tells us how to fix it. Yeah, it does. Okay, so anyways, build it, run it, and we'll watch it. Once per second. Well, that's not multi-threaded. It's only one counter. If it was multi-threaded, we'd see, two of them running at the same time. Instead, it's going to get to 20, and then it's going to start counting again. So this is still a single-threaded application because we didn't launch the threads in the correct way with .start. So what we're going to do, let's make this printout a little bit more interesting so that we can actually give these threads a name. Let's make a constructor where we can pass in something like thread 1 and thread 2. Now that I've done that, it breaks the code, of course, because I don't have a constructor. But I can fix that. I can go back to worker thread, add an instance variable, so go back to worker thread. We need to make an instance variable. String, could even be private. Name of thread. And our constructor, public worker thread, string name. This dot name is equal to name. Okay. Why are we doing that? So that we can just print the name as part of our message. So where it says print line, do print line, we're changing that line. This dot name plus And let's put a space here before the word counting inside the quote, just so that our format will look a little bit better. NetBeans wants us to add the override notation. All that does is it gives the compiler a check so that if you're trying to override a method that doesn't really exist, it'll give you an error. I'll show you what I mean. I think I've demonstrated this in the past. Suppose I thought that there was a method in the thread class called runt. Don't type this. Public void runt. All right, now it's going to tell me, no, you can't override that. You got it wrong, because there is no method named runt in our superclass. So that's what the override notation does. It provides a sanity check to make sure that you're actually overriding the thing that you think. Okay, so let's run it again. Now, as it runs, it should print out thread 1 counting 0, thread 1 counting 1, thread counter 2, and so on. And it's still going to take until 20 seconds for it to actually start calling thread 2. That's not cool, so let's launch the thread correctly. We're going to come back in here, and instead of calling .run, we're going to call .start. There we go. Now we have 2 threads counting at the same time. Create 2 more thread objects and run it. Get 4 of them going at the same time. Or let's be nuts and make an array list of worker threads, and we could create 1,000 of them and get them all running. This is stupid, but it might be fun. Let's try it. So, array list of worker threads, I'm going to call it WT list, is equal to new array list. Let's add the import for array list. So I just click on the little red arrow over there, add it. Now let's create 1,000 threads. This is idiotic, but for int I is equal to 0, I is less than 1,000, I plus plus. Let's get the name of the thread. So string name is equal to thread number plus I. Now let's make a thread. Worker thread W is equal to new worker thread, passing that name in. And let's add it to the worker thread list. WT list dot add W. Not worker threat. That's when your employees are mad at you. Now we can start all of the threads with one fell swoop. So, for every worker thread W that is in WT list, W.start. Now the output from this is going to be absurd because we're going to be launching 1,000 things. There, see, we have 1,000 things counting once per second. It's still not doing much to our, if we brought up the task manager, never remember how to do that. Start task manager. Oh, it's not showing us. Well, anyways, CPU utilization 4%. So writing a process with 1,000 threads that aren't doing much has hardly impacted the CPU at all. Now, if we had them all running one after the other, it would take 20 seconds times 1,000 for them all to run. 20,000 seconds. But instead, since they were running effectively simultaneously, it only took them 20 seconds or they're about to run. Okay. Does that make sense? Whenever you click on a button in one of those JFrame applications, it launches a thread in order to handle that. We don't see it do that, but it does. And so even if that thread generates an exception, the user interface is still valid. And you can click the button again to get another exception. So that kind of reduces the chance that you're going to write code that's going to totally disable the user interface just because one part of your code is not functioning. All right, guys, I need to take a 90-second break. I will be right back. Now I'll check to see how y'all are doing. So here's our answer for adding a timer. Controlling how long it will sleep. We created a new member of the worker thread called timer. We set it inside the constructor. You pass it in as an argument. There it is. And then down here, when we call sleep, we don't hard code it to 1,000. Instead, we do it to the timer. So that breaks our constructors. We need to pass in a value. This way it'll run, it'll print 10 times a second rather than once a second. Did y'all do something goofy like set it down to 1 or something?
Oh, no, I put mine on 3,000 so I can see the difference.
Okay, yeah. Okay, that's 10 times a second. I'm going to lower this down to 1. Woohoo! I wonder how long that really took. Okay, it took 2 seconds. So we had 1,000 threads counting from 1 to 20, and it took them 2 seconds total to run. So here is what we've added to our code. It looks really obnoxious. We're using what's known as an anonymous class right here. It's where we define our class right inside the code that's going to call w.start. So we create our thread, we do all that, and then we do th.start, parentheses in parentheses. So when we run it, we should see this anonymous running message pop up somewhere 10 times, probably up at the top, right there. So it actually did launch itself as a thread. That's kind of a really, really quick and dirty way of creating a thread. What could you do in here? Well, let's try creating a method right inside this very class. So if this is the end of the worker thread class, let's put a method in here. As a matter of fact, let's remove these 3 lines of code to that method. So cut your for statement, your print line, your closing brace, and let's just call it do it. Whatever. And we need to add a do it method down here. Void do it. And it needs to have our for loop in there. And we're getting an error. It's very possible this is not going to work. Non-static method cannot be called from a static context. Okay, so make this static void do it. So this is what we've done. We added this function, and this code is invoking it. Is there any advantage at all to declaring our anonymous class this way? Declaring our run method right inside this other one? only if you want to use variables that you declared up above. Like if you wanted to do this, don't necessarily add this, but int x is equal to 50. And you wanted to print 50 inside this stuff. System.out.println x, like that. We would not have been able to do that with our other code because it was defined in its own class, right? It would have no access to local variables. This class here does have access to all the local variables defined in our main. What happens if it changes them? Yeah, I could even change them. You can kind of run into a situation where you have multiple things changing the variable at the same time, in which case you wind up with the variable possibly being corrupted, at least temporarily. You know, what if we had 1,000 threads all trying to change x and then print x? Concurrently, they're all accessing the same memory space. And in order to write this correctly, you need to use some kind of locking mechanism which would lock that variable, let one of the threads change it, and then unlock it. And then there are some keywords that will do that automatically. Because access to that specific memory place needs to be single-threaded so that two things aren't overriding the same byte at the same time. Because what if one changed it to 51 and then the other one changed it to 52 before the first one could have printed it out? In that case, they're both going to print out, one of them's going to print out the wrong number or something like that. So when you're accessing a shared resource, you need to do locking. And honestly, I've forgotten the keyword that declares something as something that has to be locked. Why don't we Google that? And then I'll walk around and see if everybody got this working. Okay. Keyword, define, concurrent variable, Java. Volatile? Atomic? Synchronize, that's the one that I want. So I can come here, back to my code, and I can say synchronized int. Maybe I can't. Okay, I'm not going to mess with it. Oh, but I want to. Let's synchronize Java example. What is the use of the synchronize keyword in Java? It synchronizes a block of code, not a variable. So you could say, that's the wrong place to put it, that every time I print out X, I want only one piece, one bit of code to be able to do that at the same time. And you do it like that. That prevents the multi-threading version of it. And you're still going to give me an error. Okay, whatever. We're not going to demonstrate it. You got the idea. You can Google it up and learn how to do it. I'm just not looking at the examples carefully enough. You got the idea. If you have a shared resource, you have to go to some effort to make sure it's locked. The other one didn't have that problem because they weren't accessing any memory in common.
Here or here? Because you put it here, but I don't know if you got rid of it there, so it's like.
I did get rid of it
Okay,
here,
that's
so
what I thought.
instead,
I don't know if you're
comment all that out and then put in a call to do it instead. DOIT parentheses and parentheses. Semicolon.
2 years. It's free.
Transparency.
Doesn't need another one.
Roger statement. Someone said that's where Shane Carter
That's what Josh said.
You're so sensitive. I'm like,
I was laughing at you to hand us those 80 packets. We have 7 minutes. Let's talk. Not the teammates, we were all standing. Syntax is so
I
hard.
dashed it last year.
There we go. So,
If she does, we should.
This is multiple choice and it's kind of something.
she's down to like 1 millisecond of sleep.
She's also trying to see the rats. Top five. Ever seen top 5 angry kids? Close prices. Let's see what the top 6 are.
Type end space class. Just end. Space bar class.
It's like I thought you would put.
And then end,
That's true.
do it,
I don't know.
Miss Harvey does.
space
Sorry,
bar.
that's the list.
She has the list.
She just told us our rankings. Like,
She's
every-
not allowed to
Slash
tell
slash
you
front,
that.
sorry.
Oh, in front of
That's
comma.
so
Yeah.
significant, just like an ego
Main
game.
method.
Is this one need a slash
And this
slash?
one needed a slash slash as well.
Oh, I know which one.
Maybe the slash
Everyone
slash
talked
star,
about
was I do it for all of
Will,
them?
Joshua,
Blake.
Pardon me, I'm so
So I
sorry.
would do like the slash
Probably
slash.
not hard.
Like, God.
Subject.
We don't want to slash out more than one line.
Okay, okay,
Yeah.
calculus problem.
So what would have been a better way to do this? Make it not quite as anonymous. In my mind, this is overkill. You could still define a class, even right in the middle of another class. We could do class, you don't necessarily need to do this, worker thread 2 extends thread, and then it could have its own method, public, void, run. It could do something. There you've defined a class right there. You could make, new versions of it, at that point. That reduces that horrible syntax if you do that, because then it would just look like thread th is equal to new wt, and then, run it right on the spot. I'm going to delete that, but yeah. Alrighty, so what else? Let's go back and find an example of the synchronize keyword. Okay, you define it on a method, and that tells the method that it can only run one instance of that code at a time. Anything between here and there is guaranteed to only run once, one at a time, even if you have a million threads trying to call that method. It queues up access to this code so that it has to run serially. And if you put a sleep inside a synchronized call, it's really obnoxious because you're telling the computer, oh, not only can you only run one of these at a time, but each one's going to take, this would lock it for 10 times 500, 5,000 milliseconds. So for 5 seconds, it's sitting there waiting to do this. If we went and changed our code here, I guess we could go back to demonstrating this. Go back to worker thread and change. I don't know if this is going to work or not. Add synchronized run there. Okay, no, that didn't work. Go down to do it, and let's make it synchronized.
Does it go before the void?
Probably. Is that what I'm doing wrong? Okay, could I have done it on run? I could have. Okay. So yeah, go to worker thread, do that. Change your constructor to worker thread to a reasonable amount of time, not 1 millisecond or whatever. So when we create worker threads, make them 1,000. And then when you run it, you'll see that it's no longer really behaving in a multi-threaded fashion at all. Call me a liar. All right, I'm doing that wrong. What have I done wrong? So synchronize blocks the next thread's call to test as long as the previous thread's execution is not finished. Threads can access this method one at a time. Without synchronized, all threads can access this method simultaneously. So if we come back here and look, I thought that we would only see one thread able to do this counting business at a time. Perhaps it's toggling out because of sleep. I didn't think that would be true. I thought that it would be locked for the entire time. So, does sleep cause it to bail? Quite simply, other threads will not be able to enter code that's synchronized. Calling thread.sleep in a synchronized block is not a good idea. Causes the entire process to wait. Okay, ours is not behaving the way that the examples say it will behave. What we should have seen is only one piece of code.
Yes, because the two worker threads are outside of the public side void that we synchronize.
I don't think so. I'm going to try one stupid change. Oh. I have override in the wrong place now. Okay. I don't get it. It's not behaving the way it is documented to behave, so I don't want to struggle with it anymore. So I want to make sure that we all remember how to do a JFrame application, because your homework is actually to make a JFrame application that uses threading. So I need to undo all my changes that involve the synchronize keyword. I think I've done that. Okay, so new project. Next. This isn't going to work for you. Have we done any JFrame applications in this class?
I don't recognize the word.
Alrighty, I have been negligent. We will wind up doing this on Thursday, and you may have to give in and do it on NetBeans. Get on the computer if you don't have NetBeans installed on your computer.
I have it on my laptop.
Okay, so go ahead and do this. Launch NetBeans. Do File, New Project, Next. Give it a nice title like JFrame Example. What we should do is unclick this scene that says Create Main Class. I'm going to leave that there, and it's just going to create an empty class. Or it'll create a class, but then we're going to delete main. It's not going to do anything. Okay. Once that happens, delete main. Why? Because a JFrame has its own main. So there, we deleted it. JFrame Example is just an empty class. We could delete it entirely. The only reason I didn't undo that checkbox is we would have to remember to reset it the next time we ran it, and this saves that remembering business. Then do New JFrame Form. And if you don't see JFrame Form, do that on the same package, just like we normally make a Java class. If you don't see JFrame Form, then click Other, and you'll eventually find it. Does everybody see a JFrame Form option on the new menu? Miranda, you good?
I'm trying to figure it out.
Okay, just a sec.
Yeah, I was about to tell you.
So right-click, New JFrame Form. We probably ought to give it a better name than just New JFrame. And now we're in a little designer mode where we can drag stuff out from the swing containers over here and put them here. So, this is going to be a very stupid, ordinary one. Drag button over here. It says J button 1. So find button under swing controls and drag it out there. And then drag a second button out there. J button 2. And then drag text field, not text area, but text field. So we want 2 buttons and 1 text field. And if we were really awesome, we would grab a label and drag it out. And what a label is it's a description of that text field. I wish I could zoom in, guys. I know that's really small on the screen. So I'm going to right click on that label 1 and choose Edit Text and change that text to Message. I should do the same for the buttons. I'm going to leave them alone for now. And we need to stop. So what we want to do is to make it so that when you click J button 1, maybe it puts a message in the message field, in the text field. To make it easier to click, I'm going to increase the size of that button. I just grabbed it and increased its size. Now what I want to do is to double click on that button. Double clicking on it should create a method. It didn't. So I'm going to go back into design mode. Notice it says source and design. And try that again. You can get frustrated doing that. Here we go. It added something called J button 1 action performed. Now let's change that text. This dot J text field 1 dot set button 1 clicked. All right, that didn't work. Okay, this dot J text field 1 dot set text button 1 clicked. Do the same thing for the second button. Go back into design mode, make it a big button. And if you don't like the vagaries of double clicking on it to create it, you can come over here and look at events. If we click on this button 1 and under properties over here, click on events, we see that there's one called action performed and one is actually filled in. And the rest of the events are not. But I'm going to do it the other way. So I have a great big button 2. I'm going to double click on it. It creates, hopefully, a new method called J button 2 action performed. Make it do the same thing, except make it say J text field 1 dot set text button 2 clicked. So this dot J text field 1 dot set text button 2 clicked. Now, since we deleted the main method inside of our class, it doesn't know where the main method is. So the first time I run it, it's going to ask me where the main method is. And there it is. So our application comes up. We click button 1, it says button 1 clicked. We click button 2, it says button 2 clicked. So that needs to be my homework assignment, is to post for y'all the tutorial for creating a basic JFrame application, which I will do. I'm not going to do it this second. I'll do it this evening. Email y'all out a notification for the Dropbox. So there's a Dropbox called R. Upload your thread example. Put your JFrame example in there too if you want.
Why don't you put 2 dashes?
Oh no, that means it's extra for me. Maybe I'll take out the second dash. And the homework with the JFrame example video that I want you to follow will be homework 14. It'll be about the last assignment of the semester, probably. Getting close to it.
You just want us to put everything from JFrame in there?
Yeah, I don't care if you upload the JFrame app or not. If you're going to, you should export the project and upload the entire project so that you could open it later. Otherwise, you don't get the files that the form designer uses.
Oh, it's not that. Now this,
Finally got Nebby.
I am sorry.
I had to go into the config files and change where it thought my Java folder was.